Hey, this video is on just kind of an introduction to the mole. Okay, and everything basically in our second part of chemistry is all based on this. So the whole rest of the year is really based on what's called moles. Our AP chemistry class, everything we do is in moles. So it's going to seem a little abstract, a little weird to start with, but it's not too terribly tough to understand once you do it a little bit. So a mole is just a counting unit, kind of like a dozen is 12 things. A mole of something is 6.02 times 10 to the 23rd things, a huge number. Okay, that number is really hard to comprehend. It's 602 with 21 zeros at the end of it. So it's trillions and trillions and trillions and trillions and trillions. If you counted all the blood cells in your body, you wouldn't even be close to a mole. Okay, grains of sand on Earth would be not even close to this number. So this is a very, very, very large number. If you had a mole of marbles, so like a normal sized mole of marbles, they would cover the entire surface of the Earth to a depth of around 4 miles. So just one mole, that many marbles, would cover the entire surface of the Earth, depth of about 4 miles. So the only thing we really ever count with this would be atoms or molecules. So we can have moles of atoms or moles of molecules. So here is a mole of aluminum atoms. Okay, mole of aluminum atoms. So it's 6.02 times 10 to the 23rd atoms. Give or take a few. If I peel a little piece off, I might take off a trillion atoms. Okay, maybe take off a little bit. That little piece is probably a trillion atoms gone. But if you would take a calculator and take this number and subtract a trillion out of it, your calculator will give you the same answer. Okay, it doesn't even change the number hardly at all taking a trillion out. There are lots and lots of groups of a trillion. So this is a mole of aluminum. Okay, I obviously did not count the atoms. Okay, there's a way to get that figured out. This is a mole of sulfur atoms, so 6.02 times 10 to the 23rd sulfur atoms. Here's a mole of lead atoms. So Avogadro's number, that's the mole. Okay, this number is called Avogadro's number. This is a mole of lead atoms. So all of these contain the same number of atoms, 6.02 times 10 to the 23rd. Now this is a mole of sugar, molecules, because sugar is not an atom. It is a molecule. It's a mole of molecules, which means there's a lot more atoms in there than just a mole, because sugar has lots of carbons, lots of hydrogens, lots of oxygens in each molecule. So we can have moles of atoms or moles of molecules, a little bit different. We'll worry about moles of atoms for right now as we're doing things. So if I can say I have 2 moles of something. So if I had 2 moles of aluminum atoms, if I had 2 moles of aluminum atoms, it means I would have 12.04 times 10 to the 23rd atoms. I could have half a mole, meaning I have half that many atoms. I can have 1/10 of a mole. So you can have parts of moles, just like you can have part of a dozen, you can have parts of moles or multiple moles as you're counting things. So it's an easier way to count things than just counting individual atoms as you're counting things, because there's a lot of atoms and stuff. All right. Now, you might wonder, how do I know this is a mole? Well, if we go to the periodic table and look at aluminum, let me do that real quick. Go to the periodic table and look at aluminum. Here's aluminum right here. And if you remember from earlier in the year, this number, that 26.98, we have said is a number in AMUs for a single individual aluminum atom. Well, we're not ever going to mess with one individual aluminum atom. We're going to mess with lots of them. So a guy named Avogadro along the way figured out that if you have 6.02 times 10 to the 23rd aluminum atoms, a mole of aluminum atoms, they weigh that many grams, 27 grams. So if I put this on the balance right now on the scale, this would weigh 27 grams, and it'd be exactly 1 mole of aluminum atom, 6.02 times 10 to the 23rd. Well, here is sulfur. So sulfur, 32 grams is 1 mole of sulfur atoms. Because sulfur atoms are bigger, they have more protons, neutrons, electrons, it takes more grams to make a mole. So same number of atoms, these are heavier because each atom is bigger. It's like some people are bigger, some atoms are bigger. Here's a mole of lead. This one is substantially more massive. Okay? A mole of lead is 207 grams per mole. So this is 207 grams of lead, but it's still only 1 mole of atoms, 6.02 times 10 to the 23rd atoms. So if I said, okay, I want you to get 2 moles of oxygen atoms. Well, 1 mole of oxygen atoms would weigh 16 grams, so 2 moles would be 32 grams. So we can figure out how many moles we have of something by finding the mass of those things. So a mole is 6.02 times 10 to the 23rd atoms, and the mass of a mole is different for every element. So 1 mole of atoms is the same for every element. The mass of a mole of every element is different. So a mole of helium atoms is only 4 grams, because helium atoms aren't very big. It doesn't take very many grams to make a mole of them. A mole of hydrogen atoms is only 1 gram. So if you have 6.02 times 10 to the 23rd hydrogen atoms, it's only going to have a mass of 1 gram. So this is a way to compare masses and mole and number of atoms between atoms. All right, 1 second. All right, so here's some questions. These I would call non-calculator questions. So a lot of times we have to figure things out with a calculator. These would be ones we could figure out without a calculator, but we do need a periodic table in front of us. So you probably want a periodic table in front of you to do this. I can't pull both those up at the same time on my screen. So first thing, what is the mass? So anytime I ask you the mass of something, you've got to look on the periodic table. If I ask you a number of atoms in a mole, we know that number is 6.02 times 10 to the 23rd atoms. Okay, that number is never grams. The Earth wouldn't weigh that many grams. So that 6.02 times 10 to the 23rd, Avogadro's number, is always the number of atoms or molecules, never grams. So what is the mass of 2 moles of magnesium? So 2 moles of magnesium would be 6.02 times 10 to the 23rd doubled for number of atoms. But it wants to know mass in grams. So you find magnesium on the periodic table, and magnesium's mass is Magnesium's mass is 24.3. We'll just say 24 grams. And that's just its mass on the periodic table. That's all I'm doing. But that would be for 1 mole of magnesium. So 2 moles of magnesium, I have to multiply that by 2, would be 48 grams. So 1 mole is 24 grams. That's always the number on the periodic table. 2 moles would be 48 grams. How many moles would be in 28 grams of nitrogen? So if we find nitrogen in the periodic table, I'm going to slide over. You're going to see nitrogen here. Hopefully, you guys can see nitrogen. There's nitrogen up there. You notice that nitrogen is 14.0067, just 14. So that means nitrogen is 14 grams for 1 mole. Sliding back over. So every mole of nitrogen weighs 14 grams. Well, the question says, how many moles would be in 28 grams? Well, if 14 grams is 1 mole, then 28 grams would be 2 moles. So 28 grams would be 2 moles of nitrogen, because every 14 grams is a mole. Number 3, how many atoms? So whenever I ask you a number of atoms, your answer is going to be huge. It's going to be times 10 to a power. How many atoms would be in 16 grams of oxygen? So if you look in the periodic table, oxygen's mass is 16 grams. So this is 1 mole of atoms. This number, 16 grams, is 1 mole of atoms. So if I ask you the actual number, then 1 mole of atoms would be 6.02 times 10 to the 23rd atoms. So if you have 16 grams of oxygen, it's exactly 6.02 times 10 to the 23rd atoms. All right. How many moles would 20 grams of calcium be? If you go to the periodic table, find calcium. I'm going to slide over again. We're going to take a look at calcium so we kind of see this. Here's calcium right here. Notice calcium is 40 grams for a mole. Calcium is 40 for a mole. So the question was asking us, how many moles would 20 grams be? Well, it's 40 grams for 1 mole. 20 grams then would not be a full mole. It would only be a half a mole. So 20 grams would be a half a mole of calcium. If you want to know actual number of atoms, it'd be half of 6.02 times 10 to the 23rd. So 3.01 times 10 to the 23rd. What is the mass? Again, whenever I ask you mass, you look in the periodic table. 3 moles of sulfur. So 1 mole of sulfur on the periodic table, 1 mole of sulfur is 32 grams of sulfur. So 3 moles would be 3 times that, would be 96 grams. You can't see that. So 1 mole of sulfur is 32 grams. 3 moles is going to be 3 times that, would be 96 grams. All right. One more question here we'll look at. How many atoms would be a half a mole of any element? Doesn't matter what element it is, because we're not asking about mass. So a half a mole, 6.02 times 10 to the 23rd is a full mole. A half a mole is 3.01, so half of 6.02. Still times 10 to the 23rd, though. So that'd be a half a mole of any element. Half a mole of any element. Okay. We'll do one more question here. If you had a 5-gram sample of hydrogen, how many moles would you have? Okay, 5-gram sample of hydrogen. Well, for hydrogen, 1 gram equals 1 mole. That's only true for hydrogen. No other element like that. 1 gram equals a mole, so 5 grams would be 5 moles, which means to be 6.02 times 10 to the 23rd times 5 for number of atoms. All right, there's a quick intro. Next video will be on how to do some of the math problems actually using a calculator.